Okay, so we're going to look at perspective, and especially how some people confuse this perspective thing, especially when they try to explain why Polaris on a flat Earth, where it's supposedly not very far away, how Polaris can seem to be just above the horizon when you observe it from the equator. And the important thing here is this angle. And we see what common sense basically tells you is that if you move away from something, like here, we see that this angle decreases. That is, in your field of view, the object, even though it's just as high above the surface of the Earth, will seem to be lower in your field of view. So we go back to where we started, and likewise, if we move closer to an object, we see that this angle increases, and even though the height hasn't changed, it will seem like it's higher in the sky. So here we're looking at a similar situation, only scaled down. Maybe it's easier to visualize. So we're 1 kilometer from an object that is 500 meters tall. And we'll see that this angle is approximately the same as with the Polaris observation. The reason that it's not exactly the same has to do with the height of the observer. So we'll see that if we take a look at these angles, we'll see that if we lower the height of the observer to 0, that is, it's on the ground level, these angles become exactly the same. So again, we'll see that, as expected, if we move further away from this object, this angle gets smaller, and it will seem like it's not as tall as it was when we were standing closer. And if we move closer, we'll see that the angle gets bigger and the object will appear as taller. So here we're at the smallest scale. We're 100 meters from an object that is 50 meters tall. And this is hopefully quite easy to visualize how that would look in the real world. And again, if you move further from an object, this angle gets smaller and this object will seem smaller. That is not as tall. And if we move closer, this angle gets bigger. And obviously, if you're standing really close to a 50 meter tall object and you're like 25 meters from it, it will take up all your field of view. So now we're going to zoom out. Another way of looking at this is that we know the angular resolution of the human eye is around 0.02 degrees. And let's see how we can get that angle. So we'll lower Polaris to 3.5 kilometers. And we see that we now have this angle. So which means that Polaris will seem to be just above the horizon. It's very hard to distinguish between the horizon and Polaris. And 3.5 kilometers is, commercial flight height. And we know that Polaris is not that close. The other way we can look at this is if we try and move the observer. and we'll see that this is basically multiplying the distance by a factor of 10,000 or 1,000. But we see that if we move this observer way back and we keep the height to Polaris as it is, we get around 0.02 degrees. So let's zoom out and see how far away this is.